Good morning. In the previous session, we discussed about the what is the clustering, what are the why you are using the clustering, and then some of the approaches for the clustering, and then what is the difference between the clustering and classification. Now we are going to know about the partitioning methods here. Here you have a major clustering approaches. Different clustering approaches are there: partitioning, hierarchical, density based, and then grid based. Here in this session, you will know about the what is a partitioning method. How can you what are the different types of partitioning methods? How can you apply based by using WEKA tool and so on. Here, what is a partitioning approach here? Here, the partitioning approach, here you have a data set is there. Here, that particular data set divided into different partition and then evaluate them by using some criteria. Here you have a data set. That particular data set divided into different partitions. Here you are using the nk different partitions here. It may be a two partitions. It may be a three partition. That means n number of partitions here. Here that means but for example, minimizing the sum of the square errors. Here based on a criteria, the criteria here is a minimizing sum of the square errors. Here that is a criteria. That means the partitioning method first create an initial set of k partitions here. Here you are taking the k different partition here, the k number of partition to the construct. Here that means how can you get the k different groups? Here you how can you selecting, you have some doubt is there. Here how can you selecting the k value here? Here based on some process at a nearest k value based on a sum of square errors. Here on particular time sum of square errors, that means showing a particular point, the point, the particular point, here you are selecting the k value. And then here iterative relocation technique here. It is a iterative relocation technique here for to improve the partitioning by moving object from one group to another group. Here one group to another group. Here this is the what is a relocation here. Here first you are selecting the one group here. Here it is based on a similarity here. Here in that particular group another group is a similar one, then you will move this element to another group, this object to another group. That's why it is called here iterative relocation technique here. Here typically you have a three different partitioning approaches are there. Here one is a k-means approach, other one is K-medoid approach, other one is a clustering large application. Here three different approaches are there. In this session you will know about the k-means algorithm, k-means and then K-medoid algorithm. Here three different two methods are there. Even though that means you will know about the k-means and K-medoid. The first one here is a k-means algorithm or k-means clustering approach. Here what is a k-means clustering approach? Here k-means, here nothing was there. K means in the sense, here you have a data is there. I explaining about the k means. Here you have a data is there. Here dividing the data into k number of groups. Here k number of group. Each and every group you are selecting the mean value of object. Mean value in the sense centroid point. Each and every group you are selecting the centroid point. Here allocate the centroid point, the similar point to the particular mean, similar points to a particular mean. In this way you are performing the allocation. Here the k means algorithm is a partitioning clustering technique. Here it is a centroid based clustering technique. Here the clustering is unsupervised learning. Here unsupervised learning in the sense, here no predefined classes, here not having any predefined classes. And then similarity here, that means it is unsupervised learning. Here no predefined classes are there. Group of similar objects, group of similar object that differ significantly based on some distance. Here this distance already is explained about this particular distance. Here how can you calculate the one object to another object? Here Based on this particular distance, here you will calculate the K similarity. That means always similarity will identify based on a distance here. Here first it creates the K initial clusters. Here the number of cluster needed from the data set by by selecting the K rows of data randomly from the data set here. Here the K-means algorithm calculates the arithmetic mean of each cluster formed in a data set. Here a very important point here is it will calculate the arithmetic mean from the different data set here. Here sum of square error criteria here. Here how can you get the sum of square? Here what is the need of this sum of square error criteria? For identifying the similarity between a different objects here. For that purpose you are using the sum of the square error concept here. Is a sum of square error for all objects in the data set. Here P is a point in a space representing a given object. And then what about the MI value? MI is a mean of the cluster. What about the CI? CI. Here CI is a both P and MI are the multi-dimensionally in this case here. Here the CI indicates that num clusters C1 one cluster, C2 another cluster. Here that means total number of cluster in this case here. The algorithm, what are the inputs for this algorithm? That means the number of cluster and then data set. Here two inputs are there here. The number of clusters. What about the output here? K different clusters here. Form the K different clusters here. For example, you have a data set like this. Here different objects are there. Here in this case, assign each object to the most similar center point here. Here that means before that you have to identify the center point here. Update the cluster with mean. Here the red mark indicates the mean value in a cluster here. Here the first you have a data set in this way. That means you will form the two different clusters. Here you form the two different clusters. Here update two different clusters with the help of mean. Here rearrange the these clusters here. Here whatever may be the near to the mean, that's value from that particular cluster, and then update the cluster with the mean like this. Finally you have a here k equal to 2. That means number of cluster in this case here 2. In this way you will perform in the k means algorithm here. Here the once again repeat here. Here you have a different class, different objects are there. Here you will form based on a k value, k equal to number of clusters here. Here select the k as a initial cluster center. Here for each and every cluster you identify the mean value. Here this is a red mark indicates the mean value, and then reassign those values here. Here whatever may be the object similar to red mark, here we will form a cluster and then final cluster value like this. This is a k-means algorithm. The algorithm process here. Here the clustering of set of objects based on a k-means method. Here mean of each cluster is marked as a plus. Here the plus indicates you have the initially the cluster different clusters are like this, and then assign a mean value for each and every cluster, and then you have a these values are similar, that's why you will form the cluster like this. Finally cluster here, that is a representation here, the step-by-step process for this cluster here. Here the first step here is a you have a data set like this here. Here you have a the all circles indicates the all are objects here, and then some different triangles are a centroid point here. Here identify the centroid point for the nearest value. Finally you got the different cluster information. Here the algorithm. Here what is the algorithm of k-means algorithm? How can you do the k-means clustering algorithm? Here the first step here is a partition the object into k non-empty sets. The algorithm in the first step here is a partitioning, k partitioning here, and then compute the seed point as a centroid of the here. What is the seed point here? Mean, the mean value. First you identify the number of clusters here. Here in this case two clusters are there. Here Otherwise, if you take this one here, first identify the k number of clusters. K equal to 2, 2 number of clusters. Identify the 2 cluster. What about the second point here? Among these point here, identify the seed point, or seed point equal as a mean of the cluster. Mean of the cluster. And then comes to the third point here. Assign each object to the cluster with the nearest seed point. Assign each object to the cluster with nearest seed point. Seed point in the sense mean. Whatever may the object nearest to the mean, that value assigned in a cluster here. And then go to step 2. Here in this case, assign a value. This value here reassign. That means Mali again go to step 2. Mali again comes to here. In this way, we will perform. Go to step 2. Stop when no more new assignments are there. If there is no more assignment, then stop here. This is a algorithm here. That is a algorithm here. And then for the k means implemented in a different steps here. First, the k means the same representation here. The starts with the k centered by putting them at random place. Here k equal to 2. Here the stars indicates the means of a each cluster. Here divided into 2 clusters. And then compute the distances of every point from the centroid. Here the red mark star indicates the centroid. Compute the distance of every point from the centroid and cluster them accordingly. Here you have to perform the cluster accordingly, and then adjust the centroid so that they become a center of the gravity for the given cluster. Adjust the based on like this, and then reassign reassign the cluster the based on a different point. Here additionally these 2 points come here, 1 point go to the another cluster. For example, it's a cluster, it's a b cluster. Here assign adjust centroids. Here in this way you will assign the centroid and then recompute the cluster and repeat this data point stop when changing the clusters. Here this is a something about the k-means algorithm. Some component, some of the comments about the k-means algorithm. Here strength, what is the strength here? Here the efficient order of tkn. Here what are the t is iterations, and then k is a number of clusters. Yeah, that means that is a information. Some of the comments here often terminates at a local optimum. Here the weakness of this k means cluster here applicable only when mean is defined. The one first weakness here is a you always define the mean. Then what about the categorical data? That means this particular k-means cluster, you have to identify the mean value, but it's not applicable for the categorical data. Here only applicable for the numerical data. If it is a categorical data, it fails. The k-means algorithm fail. Another second important weakness here is you need to specify the k. Every time you need to specify the k value, the number of cluster in advance. Unable to handle the noise data and outlier data. Your K-means algorithm unable to handle the noise data. You are not suitable to discover the cluster with non-convex shapes. Here you will implement this K-means algorithm by using WEKA tool. Here for that purpose I am taking the that means open the WEKA tool here. Here WEKA tool, like the WEKA tool explorer like this here. In this case, I'm going to open the file. Here the data set here is the iris data. That is a general data set for this. For that means it is available internet or iris data. If you type iris data set, it's having some identified information. Here it is a high risk data set here. Here if you're editing here, it's having the 1 2 3 4 5 attributes are there, and then sepal length, and then sepal width, and then petal length and petal width and variety. Here this is a data set here. It consists of a n number of rows here. I don't know exactly number of rows it is having. That means more than 100 rows are there. Here this is a simple data set. Here this can be, how can you apply the this particular k-means algorithm for this one? Here you have a five different attributes are there. Here in these five attributes here, I'm going to applying the k-means algorithm. How can you form the k-means here? Here I'm taking the use data set here, selecting the k simple means. For example, here in this case here, the clusters are there, different clustering algorithms are there. One is a the different algorithms are there. In this case, I'm taking the simple k-means algorithm and then start. If you start here, it is having the different information. Here what is a scheme, and then a relation is Irish, and then instances are the number of instances for this one, and then attributes, five different attributes: sepal length, sepal width, and then petal length, petal width, and variety of information. And then here coming to the idea here, that means how many, what is the k here? The first initially I am selecting the k value here. What is the k value here? If you comes to here, the k value, this is a, that one here, this is a k value here. What is the k value here? K, I'm selecting the k value as a 2. The number of iteration, if you click on here, the simple k means, here if you click on here, it shows the what is the k number of clusters equal to 2. Here the number of clusters equal to 2, then evaluate this one. If you evaluate, visualize the cluster assignment, here it is having three different clusters, I think. That means two clusters are there, red cluster and then yellow, the blue, I think blue clusters. One is a red cluster. That means you, I think it's having the similarity, three different, perform the three different similarity. That's why better to select the k as a 3. Here I am taking the k as a 3. Yes, I am taking the k as a 3. Here what is the result here? That means in this case here, two different clusters here, the cluster related information here. At the time of selecting the two, this is a cluster related information. Here I am taking, now I am taking the k as a 3 here. Yes, here cluster 0, cluster 1, cluster 2, and then the percentage value 33%, 33%. Each and every cluster have the 33%. If you visualize this one, yes, three different clusters are there. Here additionally green is there. Green, this is a one cluster, this is another cluster, this another cluster. The points are arranged like this. Here this is a way of representing the cluster related information. Here comes to the data. Here this is a k-means algorithm. Here the weakness here, what are the weakness here? It is the weakness applicable when mean is defined. When mean is defined here, here okay, when mean is defined here, that means need to specify, every time need to specify the k value here. Initially you have to specify the k value, handle to noise. That means it cannot handle the noise data. That is a some drawbacks, some weakness in a k-means cluster. Here some of the few of the variations of the k-means method here. Here this is not handling the, that means the few variant of k-means with different selection of initial k-means, dissimilarity of calculation. That means similarity among the calculation strategies to calculate the cluster mean. Handling the categorical data, that means k modes. That means it's very difficult to handle in the categorical data. Why? Because every cluster you have to identify the mean value. That is why, that means another important method here is a K-medoids method here. Here the k means algorithm sensitive to outlier. Here it cannot handle the outlier data here, since the object with an extremely large value may substantially distort on the distribution of the data. Here K-medoid here. The instead of taking the mean value of the object in a cluster as a reference point, here instead of mean, you will take the reference point. The reference point also called as a medoid. That's why it is called here K-medoid. Here in this case here, not taking the mean value. Here you are taking the reference point. That's why you are taking the reference point. No need to calculate the mean value. That's why it is applicable. That means it will works on a categorical data. Here medoids can be used, which is mostly centrally located object in a cluster. The centrally located object here, that is called medoid or reference point. Here for example, here not having a one reference point, you are taking the not a mean value. You are, if this is a reference point, any point among this point here, you will take the any point. Here I am taking the reference point this one. Here in this case I am taking the reference point this one. That means centrally located object. Centrally located object as a reference point is a, here in this case this indicates the medoid point. Their representative object, we call it as a medoid in a cluster. Here partial partitioning around medoids. Here how can you perform the partitioning around the medoid? Here starts from the initial set of medoids. First it starts from initial set of medoids. Here you have a one two medoids are there in this case. Initial set of medoids, and iterator will replace one medoid by the non-medoid. Here you have a, this is a medoid point. Here this is a non-medoid point. Replace the, that means the replace relocation strategy. Here it is not medoid, replace with not medoid, then this particular not medoid as a medoid point. Here replace a non-medoid if improves the total distance of the resulting clustering. Here partitioning around monoids works efficiently for small set of data. Here, but if we say eliminates the drawbacks from the K-means algorithm. Here K-means algorithm drawbacks here is a, every time you have to calculate the K value, and then every time you have to calculate, that means for each and every cluster you should calculate the mean value. It's not handle the noise data, it's not handle the categorical data. But here it's categorical data, but here it's small data set. The data set size is a very small. If it is the K-medoid works, the data set is very large, but does not scale well for the large data set. This is a medoid algorithm. Here typical medoid algorithm points here. Here the first thing here is a K equal to 2. I'm taking the K value for the 2 for this data set. Arbitrarily select the K object as the initial medoid. Here this is a one medoid, here this is another medoid. Assign each remaining object to the nearest medoid. Here these points nearest medoid points, these points also a near, and the next randomly select a non-medoid objects. Here randomly select the non-medoid in this case, and then compute the total cost for the swapping, and then iteration. Then again go to step 2. In this way you will works the K-medoid algorithm. Partitioning, that's called here partitioning around medoid. This is a algorithm. Some of the issues in a clustering, the accuracy, that means in the first we discussed about the issues here. Examples of clustering application: marketing, land use, insurance, city planning. The application: pattern recognition, spatial data analysis, and then geographical information system, cluster weblog data to discover the credit approval, target marketing, and medical diagnosis. This is a something about the different application. Thank you.